Okay, so this is what we ended on yesterday, figuring out that our ordered pairs on the unit circle were actually cosine and sine, right? So now I'm going to have you, we're going to look a little bit more at tangent using this triangle right here. So what I want you to do, and you can use your line tool in Cami, you don't have to, but it might be helpful. And I'm not sure exactly if you can really make a perpendicular line in Cami, but I can, so that's what I'm going to do. We're going to draw a line that is tangent to this circle at this point right here. And you're going to draw right through your numbers, which is fine. So it'll look, hang on a second. It'll look something like this. Okay, so tangent to the circle, which means it's just going to intersect that circle. Okay, I feel like I didn't actually select my line, or something's wrong here. I didn't, did I? I thought I did. Okay, now let me actually do this right. Well, then my first line was pretty straight for me. I'm impressed. Okay, that way it looks a little bit better for you. And I drew right through my numbers, and it's absolutely fine. Then I'm also going to, the hypotenuse of this purple triangle, I'm going to extend it so it intersects that line right there. So I extended that right there. And then I'm going to name this point right here A, and this point right here B. And this is a right angle. So I want you to see on there that we have that purple triangle, and then it overlaps this purple and green triangle right here. And because there's so much going on in that picture, I want you to understand how it works on the circle, but I'm basically going to redraw those triangles down here. And I know you just have a very little bit of space, but I think you have enough space to at least draw and label this stuff in. You can pretend like my lines are actually straight on my triangles. So what we know from these triangles, that this length right here, this is X, this is Y, this is AB. What do you think this whole length is here? That whole length of the green part of that triangle, what would it have to be? Because it's here. 1, right? Because it is the radius. It's basically the entire radius is this part right here. So it's 1. Okay. One of the things you're still going to need to be able to do in calculus and beyond is recognize that you have, whether or not you have similar triangles. And we do. These two triangles overlap. We've got this triangle here and this one here. They overlap. They both have this angle, so that angle is congruent in both. And then these two angles are congruent. So those triangles are similar by angle, angle. Since they are similar by angle, angle, I can set up a proportion. So I'm going to say that if I put this side, which is Y, over this side, which is X, so that's this side of the little one over this side of the little one. The side that corresponds to Y is AB, so it's going to go in the numerator. And then the side that corresponds to X is 1. So it's really just that Y over X equals the length of AB. How else can we define Y over X? It's tangent theta, right? So tangent theta equals the length of AB. So this length is cosine theta. This length is sine theta. And that's how we get our ordered pair. The length of AB right here, this is tangent theta. And look at how that line segment is related to the circle. It is tangent to the circle. So when you first learn about tangent lines and first learn right triangle trig, it seems that tangent lines and tangent with trig are not related like at all. And they don't get related to each other to you in geometry, but they are related. That's why a tangent line is called a tangent line, because that's where the length comes from. That's not normal. That's not something we're always going to draw. That's not how we're going to remember it. I just wanted you to see that they actually are related. Same with cosecant, secant, and cotangent. And we'll look at all those a little bit later. It'll be kind of a little too much right now. This might even be a little too much, but I just want you to see that those things are all related in here. Okay? Are we all good so far? Okay, good deal. So then that's it for that. Let's move on to the notes for today, starting with the unit circle practice. Okay, so this is just the first quadrant of our unit circle. Okay, and we're going to talk through some things that we should hopefully already kind of feel a little bit comfortable with. Talk about the angles first. So if I'm here, my angle is 0 or 2 pi if I went all the way around. If I went all the way to 180, that's not even on here, that would put me at pi. So what is this angle right here then? Pi halves. Good. And then if I look at where my 45 is, what is that in radians? Pi fourths. Okay. So then I have two more special angles to label. It's pi sixths and pi thirds. Which one is the smaller one, pi sixths or pi thirds? When you have a fraction, what happens is your denominator gets bigger. Your number gets smaller. So this is your pi sixth. This is your pi thirds. So this is your 30 and this is your 60. The 6 goes with 30, the 3 goes with 60. So just remember that they kind of are opposite of what may be considered obvious. If we can get this first quadrant down and fully understand what's going on here, we got the whole unit circle down. Okay? Again, and I'll show you how and why and how to remember it. We're getting there. It's just like little baby steps. I haven't told you have to actually just know anything off the top of your head yet. We're still kind of reasoning through. So let's look at some ordered pairs. If I start here at 0, what is this ordered pair for this point? Is it 0, 1 or 1, 0? 1, 0. 1, 0 because you got your x value. So that means that here at pi halves, this is 0, 1. Okay, so let's talk about the values that go in the other 3 ordered pairs, which would also be the values in the other quadrants, except that they might have different signs on them. Your only options are 1/2, square root of 2 over 2, and square root of 3 over 2. Those are the only 3 things we have to choose from, period. Okay, unless we put negatives on them, obviously. So let's talk about, well, which one of these 3 special angles has an x and a y value that are the same? Okay, yes, but which angle? The pi fourths, okay, the 45, so the pi fourths. And it is the square root of 2 over 2. So I can put that in here. At pi fourths, this is square root of 2 over 2, square root of 2 over 2. Look, the one that has all the 2's in it goes with the 4's that are the 4 angles, the fourths angles. So we've used this. So now these are the 2 that I have left. So what we have to do then is just keep them straight, which is which. And I'll give you a different way to do it today than what I'm about to say, but here's one way. When I get to this point, what has to be bigger, my x value or my y value? My x. I go to the right farther than I go up, right? So this is square root of 3 over 2, 1/2. And then this one is 1/2 square root of 3 over 2. Everybody good so far? So do you see how you can kind of build it? It's not just a matter of rattling off the numbers and not getting them right. So let's talk tangent, right? We know that tangent theta is it sine over cosine or cosine over sine? Sine over cosine. So it's sine theta over cosine theta. So right now we're going to figure them out, and then we'll talk about how we can just know what they are. So let's look at this one right here. If I want to find tangent theta, it's sine over cosine or y over x. So if I put 0 over 1, what do I get? What's 0 divided by 1? 0. So my tangent value is 0. I'm going to put it in a box. Here, I'm going to put y over x. So that's going to give me 1/2 over square root of 3 over 2. So that means I'm going to get 1/2 times the reciprocal. So the 2's cancel out. So I end up with 1 over the square root of 3. What is that once I rationalize it? Square root of 3 over 3. So this tangent value is square root of 3 over 3. So then I'm going to look at pi fourths. And I'm just going to mark that out because I don't want it to be a focus of what we're doing here. Pi fourths. I'm going to put y over x. If I put the square root of 2 over 2 over the square root of 2 over 2, what do I get? It's an easy question. Don't overthink it. What do you get if you put 5 over 5? 1. What do you get if you put a monkey over a monkey? 1. What do you get if you put square root of 2 over 2 over the square root of 2 over 2? 1. Identical things cancel out and give you 1. So this is 1. That's it. Doesn't matter that it has square roots or it's fractions. It's weird. If they're identical, they reduce down to 1. So then when I get to pi thirds, y over x, I'm going to get the square root of 3 over 2 over 1/2. So that gives me the square root of 3 over 2 times 2 over 1. So that's just square root of 3. Then when I get to pi halves, I'm going to put 1 over 0. What does that give me? It's not 0. Undefined. You cannot divide by 0. It's undefined. So at pi halves, the tangent function is not defined. So on here then we have our sine, cosine, and our tangent values. That's the 3 of the 6. But once we get these 3 down, the other 3 are just the reciprocals. So on here we have, let me do this correctly. Your ordered pairs are cosine theta, sine theta, and then your tangent is boxed, so you know what's what on here. Sine and cosine and sine are always in ordered pairs. The tangent is just boxed on here because we did that. It's not like it's a rule or something. Yes? Not, well, yes. They are the slope on the, they are the slope of the radius in a unit circle, yes. Yeah, because it's y over, well, it's the change in y over the change in x, and since this is 0, then yes, basically it is like the slope. And if you think of it that way, then you can remember that the y goes on top. That can be helpful. Okay, everybody good so far? Okay, so let's talk about the tangent values and how to remember those. Okay, one way to remember them. Because remember, this stuff just gets repeated through the other quadrants. We just change the signs depending on what quadrants we're in. And so the 0 is at 0, and then you have undefined. So you're just going to have a way to make sure you understand which is which. Then you just have 3 options. Well, pi fourths is easy because it's 1. Then if you look at these two, it's either square root of 3 or square root of 3 over 3. The one that has the 2 3's in it goes with the 6th angles. The one with 1 3 goes with the 3 angles. Okay? So 2 3's make a 6. You can kind of keep it straight that way. All right? Any questions at all? All right, so let's look at, so this next page, it's blank. We're not going to do anything with it right now. It's really for you just to have a blank one. If you want to go and practice filling stuff in, you could always just sketch something and fill it in randomly too, but I just wanted to put an extra one in there for you. Before we get to the next page, we're going to do something a little bit different here. Alrighty, so if you are watching this video at home, you should have your hand traced on a piece of paper, and you should have a hand cut out because I asked you to do that stuff before you got to this lesson. And so you don't have this paper with the words on it if you're at home, but that's okay, right? I'll get you through what you need to do here. If you're at home, I told you to trace your right hand and cut out your right hand. What we're really looking at is the left hand palmed up. But basically that's the same as kind of the mirror image of your right hand. I just didn't tell you to trace it like this because I tried to trace it and draw it like this, and it was a complete disaster because I wasn't coordinated enough. So I just figured that would be easier. All right, so here's what I want you to do. I want you to take this hand, and you're going to put it down right on top of this one, so it kind of covers it up, so you know you have it turned the right way. Then you are going to flip it over, and you're going to put some glue just on the palm. So not on the fingers, we're not gluing the whole thing down, just somewhere in the middle of the palm there. And then flip it back over and place it down. Ugh. Okay. So what we have here, what you're going to think of, now I'm giving you this paper hand so we can figure out how this works, but in the end you're really going to be using your own hand, your left hand palm up. And when you hold your left hand palm up, you want to think about your pinky being the x-axis and your thumb being the y-axis. So like this is the first quadrant here. Okay, so this is your first quadrant circle with your left hand. So we're going to label our angles then. So on the outside of this hand with it completely flat, but again, my fingers are not glued down, I'm going to write the angles. So my angles here, this is 0 or 2 pi. My thumb would be at pi halves because it's on the y-axis. Then my 3 special angles, there, fine, would be pi sixths, pi fourths, pi thirds. So this is going to be a really helpful tool in remembering your first quadrant values. And like I said before, once you got your first quadrant down, you got everything down because you just have to use the quadrants then. All right, so in the palm of your hand, I want you to write a big old square root, the number of fingers all over 2. And I'll explain to you what that means, but the number of fingers divided by 2. Square root of the number of fingers, I'm sorry. All right, so when we have our ordered pairs, x, y, that relate to these angles, the x value, is the x value sine or cosine? Cosine. Okay, so the x value is cosine, y value is sine, so let's go ahead and write that up here again. So this is cosine theta, sine theta. So anytime you have an ordered pair, your x is always on the left, your y is on the right. Yes? So here's how this works. Your index finger right here, actually let's do this first. Go ahead and take all of your fingers and bend them back and crease them, but then put them back. So let's just go ahead and get a crease in them. So that is like you with your actual hand just being able to, just bending your fingers back like that. Okay. So let's talk about this square root of the number of fingers over 2. If I take pi thirds, okay, which is my index finger, and I bend my index finger back, boom, I'm at the pi thirds angle. Then to the left of this finger, I have 1 finger left, which we're not going to debate whether a thumb is a finger or not. It's a finger for these purposes. And so I have 1 of them. What's the square root of 1? 1 divided by 2, which is 1/2, right? I have 3 fingers to the right of it. So if I do the square root of 3 over 2, that's my y value. This gives me my ordered pair for pi thirds. To the left of it, I have 1, so that's 1/2. To the right of it, I have 3, so I have square root of 3 over 2. So if I ask you, what is the cosine of pi thirds? You can bend back your index finger. You have 1 over here, so the cosine is 1/2. The sine is square root of 3 over 2. We'll put that back. We'll take our middle finger, which is pi fourths, bend that back. Well, I have 2 fingers to the left of it, so my x value is square root of 2 over 2. I have 2 fingers to the right of it, so my y value is square root of 2 over 2. Right, remember 45 is the one that's the same, so hopefully those numbers, they make sense to you, right? So if I ask you whether it's sine or cosine, it's the same. If I take pi sixths, it's my ring finger, I bend that back. I got 3 fingers to the left of it, that's my x value, so that's going to be square root of 3 over 2. I got 1 finger over here, so that is 1/2. It even works for the other ones that, again, everybody seems to have really a lot of trouble with the 0, 1, and the 1, 0. If I take this finger and I bend it back, I'm at 0 or 2 pi. Then I have 4 fingers to the left of it. What's the square root of 4? 2. Divided by 2 is 1. So my x value is 1. How many fingers do I have to the right of it? None. So it's 0. Exactly. 1, 0. So then when I do my thumb, to the left of it I have no fingers. So that's 0. To the right of it I have 4. Square root of 4 is 2 over 2 is 1. So even if you could get the 0 in the right place, you know the other one is 1. So with this, then, what is the cosine of pi sixths? I would take my ring finger, boom. Cosine of pi sixths, square root of 3 over 2, right? So you have this paper hand to play with, right? And if you're at home, you don't have all these words down here, it's basically just what I said anyway. It's just explaining it. So let's look at, just use your own hand and the whole purpose of this. If I asked you for the sine of pi thirds, so this is my pi thirds because that's where it is in the first quadrant. The sine of pi thirds, this is cosine, this is sine, so the sine is square root of 3 over 2. What if I asked you for the cosine of 2 pi thirds? So the first thing I want you to think about is 2 pi thirds. What quadrant is that in? 2 pi thirds is in the second quadrant, right? It's in the second quadrant, so the cosine, would the cosine be positive or negative? Negative, because it's an x value. Okay, so now that I got that it's negative, is 2 pi thirds, so I use my pi thirds. Cosine is going to be 1/2, but I know it's a negative 1/2 because I'm in the second quadrant. Okay, do you see how you think through those things? Anybody have any questions on how the hand trick works? Anytime I give a quiz on this, it always looks like you're sitting there playing air guitar trying to figure things out. And that's fine. It's what I do too. I don't have this thing memorized. I don't suggest that you do memorize it. You understand how it works and you think your way around it. Okay? Okay. So let's go back. Okay, so we're back to our practice notes, and we're going to be here at this first big circle that we have. Do not get ahead of me on this, all right, because I want to talk you through 2 different ways to think around this circle just for the angles, and then how you actually think through it, I don't care. I just want to show you that there's different ways you may do it, something completely different as well. I also want you to understand what I'm talking about when I say certain things, even if it's not the way you're thinking about it. So all we're going to do on here is we're going to put the angles. That's it, all right? So we're going to start here with 0 and 2 pi. 90 is pi halves, 180 is pi. If I think fractionally around the circle, this is 0, pi halves, 2 pi halves, so this is 3 pi halves. Okay. Should be able to go ahead and get the first quadrant in pretty easily at this point. You got those 3 special angles. Your smallest one has the largest denominator, so this is pi sixths, pi fourths, pi thirds. All right, so we're going to get our pi fourths angles on there, and they are, these right here that are halfway through the quadrants on each one, right? So I'm going to have pi fourths. Then if I think fractionally, this is 45. If I go another 45, this is 2 pi fourths, which becomes pi halves. Then this is 3 pi fourths. Then that makes this 4 pi fourths here. And then I keep going to 5 pi fourths. Another 45 gives me 6 pi fourths, which reduces to 3 pi halves, which means this one is 7 pi fourths. And then I would get to 8 pi fourths, which is 2 pi. Okay? So then let's look at pi sixths. They're every 30 degrees, right? So this is pi sixths. This would be 2 pi sixths, which is pi thirds, right? This would be 3 pi sixths, which is pi halves. This would be right here, 4 pi sixths. What does 4 pi sixths reduce to? 2 pi thirds. So this was 4 pi sixths. That makes this 5 pi sixths. This is 6 pi sixths at pi. So I go one more, and that gives me 7 pi sixths. This gives me 8 pi sixths, which is 4 pi thirds. This gives me 9 pi sixths, which is what? Wait, no. Did I do that wrong? Oh, I did that right. I'm sorry, what? This is 7 pi sixths, 8 pi sixths. No, that's right. 9 pi sixths. This is 9 pi sixths, which reduces down to 3 pi halves. So then this is 10 pi sixths, which is going to give me 5 pi thirds. Then this gives me 11 pi sixths, and it doesn't reduce, and then 12 pi sixths. All right, so that's how you can think fractionally, but clearly I even messed that up, so may work best for you, may not, but I'm going to show you a different one here in just a second as well. Kind of another one of the patterns that are in there. So the next page, you have another blank circle like that. And again, don't get ahead of me, because I might need you to help me out if I mess up. All right, so we're going to start with our quadrantals again. So 0, 2 pi, pi halves, pi, 3 pi halves. Then we can get our first quadrant in, pi sixths, pi fourths, pi thirds. So the next thing we're going to do is just get our denominators in. Because remember, we have a whole lot of reflections going on, and why radians end up being a lot easier than degrees here. So let's just go and put all our little fraction bars for these. So if you remember when we looked at, we did the activity and you had like what I call the butterfly effect, all of your sixth angles were closest to the x-axis. So this one has to be a 6, and it's a reflection. You see the 6 and the 6, so this is 4 and 4, 3 and 3. So then this reflects down here, which makes this 6, 4, 3. This reflects over here, which makes this 3, 4, 6. So all your 6s are close to the x-axis, all your 3s are closest to the y-axis, all your 4s are right in the middle. In the second quadrant, the number before pi in the numerator is 1 less than the denominator for all of them. So since this is a 3, this is 2 pi thirds. This is a 4, it's 3 pi fourths. This is a 6, it's 5 pi sixths. Just 1 less. In the third quadrant, the number before pi is 1 more than the denominator. So since this is 6, this is 7 pi sixths. This is 4. This is 5 pi fourths. This is 3. So this is 4 pi thirds. And here's why that is, because that's going to help us with that last quadrant too. If we're thinking fractionally, I'm in sixths. That makes this 6 pi sixths. If I back up 1, I'm at 5 pi sixths. If I go forward 1, I'm at 7 pi sixths. If I think of these in fourths, this is 4 pi fourths. Back up one, I'm at 3. Go forward one, I'm at 5. 3 pi thirds. Back up one, I'm at 2 pi thirds. Go forward one, I'm at 4 pi thirds. That helps you figure out which quadrant you're in. So when I said 2 pi thirds, what quadrant am I in? If you think this is 3 pi thirds, I back up one, I have to be in the second quadrant. Okay, it's going to help you if you can think fractionally. Really just at the axis is really the only place you have to do it. So if I continue that thought of thinking fractionally, if this is 6 pi sixths, when I get all the way over here, this is 12 pi sixths, right? But I didn't go that far. I have to back up one. That's why this is 11 pi sixths. 2 pi would be 8 pi fourths. I back up one, I'm at 7 pi fourths. For thirds, this would be 6 pi thirds. I back up one, I'm at 5 pi thirds. Okay? So I know that's a lot of information, but I'm going to repeat myself on how to think about it. And if you really listen to what I'm saying when I decide what quadrant I'm in, it will help you. So if you get 11 pi sixths, you think, okay, that's almost 12 pi sixths. I just backed up one, so that means I'm in the fourth quadrant. And it kind of helps you figure out your quadrants pretty quickly. Okay, we good with that? Any questions at all? It's going to take some time to soak and marinate in your brain, and I understand that. I've still not said you have to memorize or know anything yet. We're just getting the information right now, okay? All right, so one last thing today. You are one really overwhelming third wheel, okay? I had a student last year show me this. She learned this from somebody else. I thought it was kind of funny. It's a good way, so I showed you your hand trick for your sine and cosine, right? This is going to help you with tangent. So let's go ahead and get our angles in here. So this is 0, 2 pi, then I get pi sixths, pi fourths, pi thirds, and pi halves. Okay, so here's one way you can remember your first quadrant tangent values. Just like, please excuse my dear Aunt Sally. If you can remember you are one really overwhelming third wheel, then when you have the R, anytime it's like a R or the R word, because the square root you can kind of think of as an R, I think is the idea here. So we start up here. U for undefined. R, square root of 3, okay, gives you the square root of 3. 1, and then really, so it's a square root of 3 again, with a fraction bar, overwhelming third wheel. Those are your tangent values. You are one really overwhelming third wheel. Just something that could be helpful. So these are your tangent theta values for your first quadrant. And again, if you know the first quadrant, you know all the rest, because any of the pi thirds angles will have the square root of 3. You just have to decide which quadrant you're in for which sign you're using, and we'll discuss those a little bit more in detail tomorrow. Okay. So on your Delta Math today, it's going to ask you the same kind of questions it did on the one I gave you yesterday, except this time it's not making you draw the angle to do it. I really want to challenge you to try and think about and figure out using your hand trick what the answer is before you look at your unit circle. If you still feel like you need to look at it to know that you're correct, that's fine. But use it as a tool and not a crutch. I don't want you just pulling it off the circle anymore. I want you to see if you can figure it out, then check yourself. And the more you do that, the better off you're going to be. Okay? So, any questions about the hand trick? And does everybody understand how it works? Okay, because again, it can be really helpful. Even if I'm not using my hand, sometimes I still picture it in my head so I can figure it out. But again, each time I give a quiz, everybody's out there looking like this, looking like you're playing air guitar, which is good because that means you're using it. You're going to need it. It's not a memorization thing. This is how you make sure you get things in the right place. All right? Any questions at all today? All right, we're going to practice some more tomorrow. We've got some more information on how to just keep all this stuff straight.